So hello again class, Engineer Kuing here, saying behind every beautiful girl, there's a man who did wrong to make her strong. Okay, so for today class, we are to discuss Module 10 entitled Heat Transfer. Okay, so yung technically class, let's first define heat. So heat, formal definition natin, heat class is a form of energy transferred from one body to another. Okay, due to differences in temperature. Okay? So, technically class, ang units niya, tatlo lang yan. It's either Celsius, Fahrenheit, or Kelvin. Okay? Conversion of these three natin itatakal. Supposedly class, alam nyo na yan no high school. Okay? So, technically class, nasa calculator rin naman siya. Okay? Next class is we are to define heat transfer. So heat transfer class is the movement of energy from a warmer to a cooler object. So laging ganun yung movement natin class. Heat travels from a warmer to a cooler object. Bakit? I-explain natin mamaya. Something on ano to? Particles thingy. Okay? So, pinaka-topic natin ngayon class is yung heat transfer or yung transfer ng heat class. So, ano yung methods niya technically. Okay? So, meron tayong tatlong methods class, three specific methods on how heat is transferred from one object to the other. Okay? So, first method class is called conduction. So, technically, our formal definition for conduction class is transferred through stationary matter. So, hindi gumagalaw class by physical contact. So, pag-usapang conduction yan class, laging meron tayong physical contact between yung dalawang objects. Okay? So, pinaka-example niyan class is yung burner stove, saka yung pan. Tapos, yung pan to the food. Okay? So, technically class, yung stove mo, di ba may apoy yan class? Mas mainit siya. So, i-heat niyo yung pan class. Okay? Tapos, yung food mo class, nakapatong dun sa pan. So, yun yung physical contact natin class. So, heat is transferred with the help of the pan. Parang yun yung medium natin. Okay? So, second method class, meron tayong tinatawag na convection. So, convection class, formal definition is heat transfer by microscopic movement of a fluid. So, keyword natin dito kasi is fluid. So, di ba ang definition ng fluid class is either a liquid or gas. Okay? So, yun. Pag ang medium natin class more or less hangin or tubig, most probably class convection yan. Okay? So an example of convection class, ito takes place in a forced air furnace and in weather systems. So, ang aircon ba? Ganun. Okay? Or simply heaters. Or, yeah. Okay? So, tuloy lang natin class. So, last method class, third method of heat transfer, radiation. So, formal definition of radiation class, ito. So heat transfer by radiation occurs when microwaves, infrared radiation, visible light, or another form of electromagnetic radiation is emitted or absorbed. So more or less class, pag may radiation, kasi it's either emitted class or inabsorbed mo, heat transfer through radiation yung galawan natin dun. Okay? So example natin class is warming of the earth by the sun. So kasi di ba umiinit yan class through the rays of the sun. So technically class meron tayong radiation dun. And thermal radiation from the human body. Okay? So yun class, meron tayong tatlo. Para mas ma-imagine yung class, meron tayong picture. Ito. So this picture class, parang it describes the three method. Okay? So conduction class, more or less, isipin nyo na lang, ito is slab. Okay? So yung apoy nun class, hinihit niya more or less yung heat magta-transfer through the slab. Tapos pag umapak ka dito class, mainit-init na siya. Okay? So conduction, again class, with the help of a stationary object. So hindi gumagalaw na object. Tapos by physical touch. Okay? Convection naman class is through fluids. Microscopic particles through fluids. So ang example natin dito class, more or less merong hangin na malamig, cold air. Okay? Dadaan yung cold air class dito sa ating fire. So, iinit siya doon. Tapos yan class, lalabas na yung mainit na air. So, technically class, may effect dapat yung hot air na yan, paiinitin niya rin somewhere dito. Okay? So, radiation in glass more or less is yung electromagnetic radiation nung kung anong rays man yon. So, technically glass meron, ano ba? Ini-emit glass yung fire. Yeah. Kaya di ba kung parang igaganon mo yung kamay mo dun sa fire glass is mainit. So, meron ini-emit yung fire glass electromagnetic radiation. So, yun glass. Heat transfer through radiation yun. Okay? So, i-summarize natin yun glass. So, ang pinaka-summary natin dun glass again. So, meron tayong tinatawag na heat. Okay? Definition natin ng heat glass is form of energy. A form of energy. Okay? So, nado-transfer siya class due to difference in temperature. So, ang units niya class, so ang possible units natin dito, so meron tayong pinakasikat, degrees Celsius class, degrees Fahrenheit, tapos Kelvin. Okay? Tapos class yan. How is heat transferred? So, ayun yung second natin. Actually, ito yung main class. Ano ang heat transfer? So, technically class, formal definition natin ito is yung movement ng heat. Of heat. So, lagi siyang magagaling class sa warmer body. Kung na natin tawagin body, sabihin natin object. So, a warmer to a cooler. To cooler objects. Okay? Tapos class, meron tayong 3 types. 3 methods. So, 3 methods of heat transfer. So, again class, meron tayong number 1. Meron tayong ng conduction. Okay? 2 class, convection. 3 class is yung radiation. Okay? So again class, ang definition natin dito, baliktad yung aking color coding. Okay? So pag ano yan class, para simple na lang, ito, by physical contact to class. Okay? Ito namang class by movement of fluids. Okay? Radiation naman class is by electromagnetic absorption. Absorption or emission. But S ba ang emission? Of electromagnetic radiation. Okay? So parang ganyang class yung pinaka-summary. So again, yan. Heat. Okay, yan yung pinaka-summary class ng ating diniscuss kanina. So mag-dwell tayo class more or less i-specify natin class. Mag-dwell tayo dito sa 3 methods of heat transfer. Okay? So unahin natin class yung conduction. So yung first method natin class again conduction, no? So ito pinaka-formal ulit natin. So conduction is a process by which heat energy is transferred from particle to particle class by collision of direct interaction. So ito na class yung explanation kung bakit ang movement ng heat class is from a warmer to a cooler. Ay, in-explain ba dito? Hindi pala. It has something to do class with the particles. Di ba magko-collide kasi yung particles nila. So more or less class parang prior, before collision kasi parang mas malakas. Kumbaga mas malakas class yung energy ng cold kaysa sa hot. Pero after collision kasi class, pag nag-collide na sila, mas mataas na yung sa hot kaysa sa cold. So itutulak na ngayon class yung cold. So more or less mananalo yung hot. So ang transfer ng heat natin class is from hot to cold. Okay? So ganun. So figure 10.2 class shows us the concept of conduction. Okay? So ganito yung pinaka-concept niya class. So meron tayo ng hot hot object. Tapos meron tayo ng cold object class, no? So meron tayong physical or stationary object in between. So ito na yung magko-conduct class ng heat. Okay? So technically class, dahil sa rod na yan, merong physical interaction class yung hot tsaka cold. So dyan na mag-transfer yung heat class. Again class, ang direction ng ating heat transfer is pa ganun. Kasi from hot siya to cold. Okay? Tapos yung class, meron tayong formula. So ang formula natin class, meron tayong tinatawag na conductive heat transfer or letter Q. Okay? So ito yung formula natin class. So technically, meron tayong change in temperature dito. Ayan. Okay, change in temperature natin class is laging hot minus cold. So more or less class yung change in temperature natin laging positive. Kasi lagi naman class mas mataas yung temperature ng hot kesa dun sa cold. Okay? Tapos ganito yung ano natin class. More or less kasi class ang pinaka-goal natin na kunin dito class is yung rate of conductive heat transfer. So di ba conductive heat transfer yung Q. Pero yung rate class, pag sinabi kasi yung rate, kasama na dyan yung time. Parang in terms of time. So more or less class, ang kinukuha natin is yung power. Okay? Or yeah. Power. So yung Q over T class, more or less, pag sinubstitute natin kanina, ito. Yan class. Ba yung Q dyan class, in over T natin, magka-cancel out yung T. Ito. So may iwan class power is equal to, or yung rate of conductive heat transfer class is equal to this one. Tapos ito class yung notations natin. Ito yung meaning. So meron lang tayong coefficient class, no? Ito rin yung mga units natin, suggested units niya. So take note lang dito class, ang nakakalito dito is yung D. So yung D na yan class, ang meaning ng D natin doon is yung distance traveled by heat. Okay? So technically class, it's either depth, length, or thickness yan. So sa example natin dito class, supposedly, ito yung D. Kasi yan class yung parang trinavel. Yan yung travel ng heat, or ito yung distance class in between yung dalawang object. Yan yung D natin. Okay? Lang naman yung nakakalito dun. So more or less class, mag-example na tayo para matapos na. So i-erase ko lang, no? Tuloy natin class again. I-summarize ko pala muna yung class, no? So again, discuss natin class is about conduction. Okay? Formal definition natin ng conduction class is yung heat transfer by through stationary matter. So hindi gumagalaw class. Matter by physical contact. So dapat class meron silang physical contact. Yan. Okay? So, meron tayong formulas class. So unang formula natin class, yung Q. Wala na, nag-return talaga yung bed ko. Okay? So Q, also known as class yan, conductive heat. Conducted. So yung heat na nag-travel, parang yung amount ng heat. Okay? So Q natin dito class is equal to, so meron tayo nung coefficient natin na K, yung area natin class, tapos yung change in temperature over yung D. Tapos times time pala tayo dun. Okay? Pero more or less class, ang lagi kasing record natin or ang pinaka gusto natin makuha class is yung power or yung rate of Q or rate of conductive heat transfer natin class. So pag gusto mo kasing kunin yung rate class more or less, divide mo lang siya by time. Okay? So ang magiging pinaka-formula natin class for rate of conductive transfer or power class is equal to T. Ay, wala na pala yan. Yan yung maalis. So yung capital T class over yung D. So titignan nyo class cut D. So yung D again class, ito yung pinaka-ano natin, no? Ang D natin dito class is yung distance between objects or yung distance traveled. Yan lang naman yung medyo ano dun. Okay? So ano yung natin kakalimutan class no, yung change in temperature natin class is equal to laging yung temperature mo na nung hot. So dapat positive lagi yan. Minus yung temperature ng cold object. Okay? So ito lang naman yung mga kailangan natin class. So with this class, pwede tayo mag-start sa example number 10.1. So i-erase ko lang ulit. Okay, tuloy natin class again. Start natin sa example 10.1 class. So dating gawin class, more or less, basahin natin yung problem, record na yung given. So dito daw class, meron tayong steel rod tsaka aluminum rod. So each of them having class yung diameter na 1 cm tapos length na ganyan. So wineld daw sila class end to end. So one end of the steel rod is placed in a large tank, may temperature na ganito. Yung aluminum rod din class, nasa isang tangke ng water class, tapos 20. Okay? Tapos yun, so the rods are insulated daw class para walang heat na alis. So what is the temperature at the joint? So yan yung unang record natin class, temperature of joint. So diba wineld kasi sila. So ano daw class yung rate? So sabi ko nga class, laging rate yung tanong. So dapat yung power yan of the composite rod. Okay, so mas maganda siguro class, i-drawing na lang natin. No? Isipin natin class, meron daw tayong rod. I mean tank, yung tank muna. So, ito yung tank natin. No? Yan. May laman siguro siyang tubig, ganyan. Okay? So, ito naman class yung pangalawa. So, dalawa kasi yung tank natin. Tapos, pagkatapos nun, so, meron daw tayo class nung steel. So, sinawsaw siguro yan, ganyan. Okay? So, medyo gitna sila. Tapos, sige, diretso na natin. Yan. Okay? So, lagyan na lang natin ng thickness. So, doon sila na weld. Okay? Ito na yung aking red. So, ito class, tawagin na lang natin. Ito yung steel. Okay? So, ito class yung aluminum. Okay? So, again class, ang nangyari dyan, device winelding sila class. So, isipin nyo lang class dito winelding. So, magkadikit daw silang dalawa. Ngayon class, nilublob sila sa dalawang tangke. Yung tangke class kung saan nakalublob yung steel, meron tayong 100 degrees Celsius. So, ito class is 100 degrees Celsius. Dito naman daw class, meron tayong 20 degrees Celsius. Okay? Tapos yung length class, wait lang class. Okay? Ilagay natin class yung properties nila. So technically class, ito daw. So diameter, no? So lagay ko na lang isa. So meron tayong diameter class nung S. Ayan, diameter nung S tsaka yung aluminum class equal to. So meron tayo dyan. Ano yan? Sabi dito class, diameter is equal to 1 centimeter. Yan. Okay? So meron tayong length class nung steel is equal to length nung aluminum ulit. So this time class 25 centimeter siya. Okay? Technically yan lang naman yung mga given natin. So since okay na yung given natin class, pwede tayo mag-start. Okay? So ang unang gusto natin makuha daw class is yung temperature dun sa joint. So paano natin gagawin yun class? So parang ito yung unang class. Ano yung temperature dun sa joint? Okay? So paano natin gagawin yung class? So dito class, isa lang naman yung formula natin, di ba? Formula lang natin class is yung rate. So kung titingnan nyo class, may sinabi siya dito. So the rods are insulated. So insulated daw yan class para walang mag-escape na heat. So ang gusto niya mangyari kasi dyan class, parang yan, may silbi yung sentence yan. Kasi parang sinasabi niya na yung power, yung P ng steel, ito na yung parang main formula natin eh. Yung power class or yung rate dun sa steel equal sa class sa rate dun sa aluminum. Kasi nga raw class insulated siya. So kung ano man yung dumaan dito class na parang heat, yun rin yung dadaan dyan, more or less. Okay? So parang yun yung meaning ng sentence na yan. Okay? So kung titignan nyo class, diba meron lang tayong formula ng P. So ang formula ng P natin class is equal to, diba yan yung cut. So A is in T over yung D. Okay? So dito parang pinakagagawin lang natin class, i-apply natin to. Kasi at some point class, diba, dun sa change in T kasi kukunin mo yung temperature ng steel tapos yung temperature ng joint. So dito magkakatalo class. So more or less, meron rin tayong temperature ng aluminum, di ba? Okay? So dito parang ang length natin class is ito, 25 cm. Okay? So ang gagawin natin class, sundan natin yung ating main equation. Okay? Makikita nyo. So unahin natin class, no? So kunin muna natin class yung power ng steel. So power ng steel class, kailangan natin gamitin class yung coefficient ng steel, area ng steel, tapos yung change in temperature ng steel. Okay? Over class yung distance ng steel. Okay? Same dito class. So dito naman sa kabila, para makuha natin class yung sa aluminum, ganun din. So kung kailangan lang natin gamitin class yung K ng aluminum, yung area ng aluminum, change in temperature class ng aluminum, tapos class yung distance ng aluminum. Okay? So dito class kung titingnan yung given naman na lahat. So direct sub lang siya. Okay? Ay expand lang natin dito class. So dito siya magkakatalo. So, saan siya magkakatalo class? Dito sa change in temperature natin. Kasi magkaiba sila. So dito so ito magre-retain no class. So expand lang natin yun, di ba? Ito class ang formula natin sa change in temperature is laging yung hot minus yung cold dapat yan. Okay? So kung titignan nyo class, ito yung una, tapos papunta doon. So kung titignan natin class, di ba laging from a warmer to a cooler. So yung travel ng ating heat class is pa ganyan. So technically magsa-start siya dito class, pupunta siya doon sa joint. So hindi natin alam yun nandito class. So technically class, mas mataas yung dito, papunta doon. Kasi di ba, again, ang concept natin class is from a warmer to a cooler body. So sure tayo class, dapat mas mababa yung dito para mag-transfer yung heat. Okay? So ang change in temperature natin dito class is yung temperature ng steel minus class yung temperature ng joint. Kasi again class sure tayo na mas mainit yung dito kaysa doon. Di ba? Ang change in temperature natin class is hot minus cold. Okay? Over class yung distance ng S. Okay? So dito naman sa kabila class, so again ito class yung power ng steel. Yung power naman ng aluminum class, okay? So retain natin class yung coefficient, yung area. So dito naman class yung change in natin. So kung titingnan nyo, again ganito yung travel ng ating heat, no? So short tayo class mas mainit dito kaysa dyan. So dapat yung nandito natin class is yung temperature ng joint minus yung temperature ng aluminum. Okay? Over class yung distance ng aluminum. Okay? So dito na tayo pwedeng mag-direct sub class. Okay? So direct sub tayo dito class. So ano ba ang K ng S? Ayun pala yung kulang natin class. Saan natin makukuha class yung coefficient ng S, tapos ano yung coefficient ng aluminum? Okay? So kung babalikan nyo class, hindi ko pala ata diniscuss. Ito, na-skip ko pala kanina class. So sa mga thermal conductive substances natin class or yung value, thermal conductivity. So meron tayong table class sa thermal conductivity, no? Kailangan mo lang malaman class kung ano yung material, makukuha mo na kung ano yung corresponding thermal conductivity niya. Okay? So again, ang habol natin dito class is yung steel. So ito, steel iron. Steel iron yan class. So, meron tayong 80. Okay? So dito class meron tayong 80. Tapos ang unit natin dito kasi is W over meter degrees Celsius. Okay? Aluminum naman natin class ito. Mahirap siyang hanapin kasi hindi siya naka-alphabetical. Anyway class, so meron tayong 220 class again W over yung meter degrees Celsius. Okay? So okay na tayo class. So balik na tayo sa problem. Yan. So again, K ng steel natin class or yung thermal conductivity niya is 80. Okay? So dito class, consistent lang natin yung units. So para sa Q, naka-J lang tayo. Para kahit yung nilagay units class, dapat consistent ka lang. Okay? So ito kahit hindi ko nilagay. Times yung area class. Wala natin sinolve yung area. Medyo masikip. Okay? So yung area ng steel class, equal rin naman yung class sa area ng aluminum kasi parehas naman sila ng diameter, no? So formula lang natin dito class is diameter yung gusto mo. So pi over 4, diameter to the fourth. Bakit to the fourth? Squared. Diameter squared. Okay? So again class, di ba gusto natin consistent tayo sa units? So dapat ito i-convert natin into meter. Okay? So meron tayong pi over 4 class times. So ito in meter class is equal to 0.01 meter. Okay? Ito namang class is 0.25 meter. Kasi meron tayong 100 centimeter in 1 meter, di ba? So 2 decimal places lang yan. Okay? So again class 0.01. Yan. Squared. Okay? So i-calculate natin yung class. So pi over 4. Ay. Pi over 4 times 0.01 squared. Okay? So ito na yung area natin class, no? Dito ko na ilagay class, no? Meron tayong 7.85. Ito na natin ikat. Negative 5. Ilagay ko dito class. So AS is equal to yung area ng aluminum is equal to 7.85 plus, no? Times 10 negative 5, malit masyado. Meter squared. Naka-meter squared kasi tayo. Okay? Times class yung ating TS. So ano ba yung temperature ng steel natin class? Diba 100. So 100 class minus yung, ito yung unknown natin class. So iwan mo lang siya. Over class yung distance. So yung distance natin class, diba? Distance ng steel lang natin class, meron tayong length. So doon naman magta-travel yan class. So yan dapat yun. So 0.25. Okay? So again class, ito na yung PS natin. Okay? Tapos class, yung ating PA. So yung PAL naman natin class, equal siya sa, again yung K. So meron tayong 220. Kasya ba? Okay? Times class yung area. So yung area natin class same doon. So 7.85 times 10 negative 5. Okay? Times class yung change in temperature natin. So yung unknown natin class na T joint minus class yung ating aluminum. So ang aluminum natin class is 20. So minus 20. Over class yung distance. So distance natin kayong class is yung length niya. So 0.25. Okay? So kailangan ko mag-erase class. I-erase ko lang yung taas, no? Erase ko yung taas class para ma-simplify natin. So kahit ito lang. So tuloy natin class. So again, simplify lang natin yan, no? So dito class, more or less, PS or yung power ng steel natin class or yung rate ng conductive transfer natin, simplify lang natin yun. So meron tayong 80 times 7.85 times 10 negative 5. Okay? Over yung 0.25 para mas makita. Ayan. So meron tayong 0.0251. Ito decimal na lang natin class times yung 100 minus yung temperature dun sa joint. Okay? Yung sa aluminum naman natin glass, so meron tayong 220 times yung area, 0.85 times 10 negative 5. Okay? All over glass yung 0.25. So meron tayong 0.0691. Okay, times yung temperature dun sa joint minus 20. Okay? So ito yung simplify pa natin class para mas madali. So pag sinimplify natin yung class, so ito 0.025, 2.51 plus minus yung 0.0251 temperature sa joint. So ito na yung PS natin. Okay? Tapos yung power sa aluminum nating class. So meron tayong 0.0691 temperature dun sa joint minus 0.0691 times 20. Yan. So meron tayong 1.382. Okay? So again, class, babalik tayo dun sa ating main. So kung titignan nyo, class, pag in-equate natin yan, ito yung parang ating main formula, class. Yan. So, equate natin yung class, meron lang tayong isang unknown. Makuha natin yung unknown na yun. Yun na yung sagot natin, class, dun sa unang tanong. What is the temperature in the joint? Okay, so ang gagawin natin yan again, class, is yung PS is equal to, yung power sa aluminum is equal to yung power sa steel. I-erase ko lang to, class. Okay? So, ilagay natin. So, again, class. So, C2 point, power ng steel, 51 minus 0.0251 temperature dun sa joint is equal to 0.0691 temperature dun sa joint minus yung 1.382. Okay? So, kung titignan nyo, class, pagsamahin na natin, no? So, ito ilagay natin sa kabila. So, meron tayo nung constant na lang sa left side. So, yung 2.51 class plus yung 1.382. Because, yan. So, meron tayo class 3.892 is equal to, so pag ito nilipat natin sa kabila, class, so meron tayo 0.0691 plus yung 0.251. So, ilan to, class? So, meron tayong 0.0942 temperature dun sa joint. Okay? So, ito na yung sagot natin, class. So, para makuha natin yung temperature dun sa joint, i-divide lang natin, class, yung 3.892 divided by 0.0942. Okay? Yan. So, meron tayo, class, 41.3163. Since consistent naman tayo sa units, class, degrees Celsius tayo. Okay? Kasi degrees Celsius naman tayo doon, pati doon sa ating constant degrees Celsius. So, ito na yung sagot natin doon sa temperature sa joint. Okay? So, hindi pa tayo tapos dito, class. Kailangan natin kasing kunin. So, more or less, class, pipili ka lang dito sa dalawang formula natin kung anong gagamitin mo. So, either ito ba, so, either lang sa dalawa, ito, or yun. Okay? So, dito na tayo sa joint. Sa steel pala. Okay? So, i-erase ko lang ulit to, class. Substitute lang natin, class, yung value ng joint dito. Makukuha na natin yung power. Kaya since equal naman, class, yung steel sa ano, yun na rin yung sa aluminum. Okay? So, again, gamitin natin, class, yung PS. So, PS natin, class, is equal to 2.51 minus 0.0251 times yung na-solve natin, class, na 41.63. Ay, 31 muna. 41.3163. Okay? So, makukuha natin dito, class, again, kung ano yung nakuha natin, yun na rin yung power dun sa aluminum. Kasi nga equal sila, class, dahil dun sa clause na the rods are insulated, so no heat will escape, something like that. Okay? So, i-calculate natin yung class. So, 2.51 minus 0.0251 times 41.3163. Okay lang yun. Okay? So, ito na yung ating sagot sa power or rate of conductive. So, 47.30. So, since consistent naman tayo sa units, class, yan na yung sagot natin. Watts unit natin. Okay? So, i-check natin, class, kung tama ba. So, kung titignan nyo, class, yeah, tama naman yung ating temperature sa joint. Tapos, yun rin yung power natin. Okay? So, tuloy-tuloy na natin, class, para matapos. So, second method natin, class, is yung tinatawag natin convection. Okay? So ang convection nating class, again, in convection, thermal energy is carried by the large scale flow of matter. Yung matter natin na to class, fluids. Fluids class, air tsaka gas. I mean, gas tsaka water lang tayo. Liquid tsaka gas. Okay? So dito daw class, meron tayong two types of convection. So meron tayong forced convection class, tapos meron tayong free or natural convection. So ano yung difference nila class? So unahin natin define class yung forced convection. So forced convection in class, ito yung flow is driven by ito yung puwersa. So it's either a fan class or a pump. Okay, an example is yung fan blows air past you, not surroundings, thus and cools you by replacing the air heated by your body with cooler air. Okay? So yun yung first more or less class. Meron tayong ito. Parang meron tayong intervention in the form of a fan, electrical appliances, okay, or mechanical ones. Okay? Pag free naman glass or natural, supposedly flow is driven by buoyant force. So natural cause class. Natural forces, buoyant force class. So, para imagine nyo ang buoyant force, ang effect kasi ng buoyant force, no, is ito. So, pag mainit daw yung fluid class, tataas siya. Pag malamig naman yung fluid, bababa siya. Parang ganito yung concept class ng hot air balloon. So, di ba hot air balloon class may ganyan? Tapos, nakasakay ka dito sa baba class. Di ba kaya siya tumataas class is parang may apoy dito. Okay? Kasi class, ang density daw class ng fluids nagdi-decrease as temperature increases. So more or less class, parang pinapainit mo class yung air natin dito. So yung pag uminit class yung air mo dyan, no, bababa yung density niya, lulutang siya. Okay? Kasi di ba ganun ang concept ng ano natin class? Kaya lumulutang class ang isang bagay sa tubig kasi lower density siya compared dun sa tubig. So ganun din sa air class. Okay? So again, class, pag forced convection, the flow is caused by electrical tsaka mechanical appliances. Pag free tsaka natural class, the flow is caused by natural forces. Specifically, class, yung buoyant force. Okay? So ito yung example natin, class. Yan. Ito. So sa ating discussion ng class, magpo-focus lang tayo sa natural. Mahirap kasi class E, ano yung force kasi kailangan mo pang i-consider class kung ano yung power rating ng mga mechanical at electrical appliances mo. Okay? At least class pag free or natural class, kailangan lang natin ng constant ulit. Okay? So ito class is an example. No? Ito ang example ng natural convection natin. So more or less class yan. No? So umiinit yan class. So again, pag uminit, bumababa yung density niya class, lulutang. Okay? Pag lumalamig class, bibigat, tataas yung density niya, so magsisink. So more or less class, meron lang tayong loop. Okay, so pag dumaan ulit class yung cold dun sa furnace, iinit na naman siya, tapos magluloop. Same rin dito class, no? So same concept. So pag nagpainit tayo ng tubig class, yan. Technically class, yan, heat transfer, hot water expands, tapos decreases in density, tapos lulutang siya. Okay? Tapos transfer to heat other regions, water, colder water sinks in the bottom. So ikot-ikot lang ulit siya. Okay? The same class, kung meron tayong formulas class sa ating conduction, meron din tayo sa convection. So ang nagbago lang dito class, ang tawag na natin dito sa Q is yung conductive heat transfer. Okay? Tapos ito na yung formula natin class HAT. Same. So power natin class, yung Q divide mo lang by T. So ang resulting formula natin for the power or yung rate of conductive ay mali to. Kung na-update class, dapat convective to. Okay? Itong ko mamaya. Convective heat transfer. Ito dapat sa class. Okay? Ito na yung formula natin. Tapos meron tayong coefficient ulit class. Ang coefficient natin this time kasi yung H. Heat transfer coefficient. Tapos for certain class, no? Situations, meron tayong value para dun sa H. Yan. Okay? Example natin dito gagamitin kaya hindi masyadong mag-dwell dyan. Okay? Tapos meron tayong tinatawag class na phase change. So more or less kasi class, di ba, hindi mo maiiwasan pag fluids kasi ang class, meron tayong tinatawag phase change. Yung liquid magiging gas, yung gas magiging liquid. So meron tayong formula dun ng gas. Meron kasing heat absorbed or release class kapag nag-change siya ng phase. So depende yan class kapag melting or freezing, vaporization or condensation. Okay? Same lang naman class. Isa lang na yung formula natin class. It's mass times ano lang tayo. Mass times yung latent heat. So it's depende lang siya class kung freezing or melting or yung vaporization or condensation. It's either fusion siya class or vaporization. So LF class stands for the latent heat of fusion, tapos LV stands for the latent heat of vaporization. Okay? So i-summarize natin class. Ano yung mga gagamitin natin formulas and all. Saka natin banatan yung example number 2.10.2. So i-erase ko muna. Again, summarize natin class. So again, ang discuss natin class is yung convection. Okay? Ang formal definition natin class ng convection is yung heat transfer natin is yung ito. By it. So heat is transferred by the macroscopic 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 movement class. So yung malakihang movement of a fluid. Okay? So again class, meron tayo na buong formula, no? So unang formula natin class is yung ating Q or yung convective heat transfer natin class. So equal siya class dun sa H, yung ating coefficient times yung area, change in temperature rin tayo dito. Okay? Times yung T. Tapos again class, ang pinakagusto talaga natin dito class is yung power. So again class, ito divided by T. So meron tayong HA. Just change in T. Okay? Ang isa pa lang hindi ko na-stress dito class. Ano? So kung titignan nyo kasi class, meron tayong unit dun sa H. Or yung coefficient natin class. So yan. Yan yung unit ng coefficient natin. So technically class, yung coefficient na yan, siya yung magdidictate kung ano yung units ng ibang notations natin. So kung titignan nyo class, meron tayong Kelvin. So dapat class, no? In terms of temperature, dapat ang unit natin lagi dito kasi sin Kelvin. Okay? Yan. So same class, dapat pag ganito yung unit na ginamit mo dun sa coefficient, dapat ang areas mo in terms of meters. Tapos in terms of watts naman class yung Q. Ibang watts kasi joules per second. Okay? So yun, stress lang natin yun. So dapat naka-Kelvin tayo kasi yung para consistent tayo sa units. Yun lang naman yun. Consistency in units class. Okay? Tapos meron tayong tinatawag class na phase change. So kapag may phase change na nag-occur class, no, yung Q natin class or yung heat absorbed or release class is equal to yung mass lang natin class times either yung LF or yung LV. So depende class kung ano yung nangyari doon, anong phase yung nag-change. Kapag vaporization class or condensation, dito tayo sa LV. Ang gagamitin lang naman natin dyan class is yung latent heat. Yun lang naman nagbabago. Pag freezing or melting class, dito tayo banda. Oh. Okay? So with that class, pwede na tayong sagutan yung example 10.2. So i-erase ko lang. Again class, sagutin natin yung example 10.2. Okay? So dito class, ang gusto nilang mangyari class is yan. What is the rate daw? So meron daw tayong an average person produces heat at a rate of, so nagbigay lang siya ganyan. Tapos what is the rate? At what rate must water evaporate from the body to get rid of all this energy? Yeah. This time class, huwag na tayong i-illustrate. Maglagay na lang tayo ng given. So ang given natin class, ano ba yung mga given natin? So meron tayong given rate or power class, no? Produces heat. Watts kasi yan class. So 120 watts. Okay? Ano pa class? So i-guess natin class, ang 120 watts is 120 joules per second to. Okay? So pang given natin class sa baba. Ito. So meron pa tayo niyan. So meron tayong given na LV. So LV class, ibig sabihin vaporization or condensation. Evaporation kasi ito, no? So dapat class is from liquid to ano. So parang vaporization din siya. Liquid to gas. Yeah. Okay? So meron daw tayo class 2430 kilojoules per kilogram. So para consistent ulit sa units, class convert natin to sa, dito rin kasi class gusto niya at the rate of grams per minute. So ito gagawin natin grams, yun gagawin natin joules. So magka-cancel out lang yan class 2430. So joules per grams na tayo dito. Okay? Na-imagine nyo ba yung class? Kasi ito, i-divide mo ba yung 1,000? Di ba? Para makuha mo yung joules class, i-divide mo siya by 1,000. Ito naman class, para makuha mo yung grams, yung multiply mo by 1,000. So magka-cancel out lang yung dalawang 1,000 class. So same number lang siya. Okay? So ano pa mang given natin class? Yun lang naman yung given natin. Okay? So with this class, pwede na tayong mag-start. So ang formula lang natin dito class, diba? Power is always equal to class to Q over T. So this time class yung substitution ng LV or yung latent heat for vaporization glassmatic, gagamitin natin yung formula natin sa phase change. So yung Q natin dito class is equal to yung M, yung mass, times yung LV. All over class yung time. Tsaka dito kasi class kung titignan nyo, ang required natin dito class is yung rate na mauubos class yung water per minute. Okay? So dito class parang ang pinaka-unknown natin class is mass over yung time. Okay, in grams per minute. Okay? So titignan yung formula natin class, kailangan lang natin makuha yun. So hiwalay lang natin class yung mass over time. Okay? So mass over time class is equal to, so yung P over yung latent heat of vaporization. Yan. Direct sub na tayo class. So again, yung mass over time natin kasi yun yung unknown natin. Okay? It's equal to yung power natin class na 2 over yung latent heat natin class na 2430. Okay? So dito class, ilan yan? So meron tayong 0.0493. So ang unit natin dito class is consistent naman tayo sa units, grams per second. So ipakita natin class, di ba, joule per second dito class. Dito naman class is joule per gram. So magka-cancel yung joule, tataas to, bababa yun. Yan. Okay? But then again class, ang gusto kasi nating unit in terms of grams per minute. So ito, i-convert lang natin. So di ba meron tayong 60 seconds class sa 1 minute. Yan. So, final answer natin class, no, yung rate para maubos yung energy na yun class is yan. So, multiply lang natin yung 0.493 times 60. So, meron tayong 2.958. So, this time class again, magka-cancel second. Second, ang naiiwan natin class is grams per minute. Okay? So kung titignan nyo class, tama yung sagot natin. Yan. Okay? So tuloy-tuloy tayo class, tapusin na natin. So ang third method class of heat transfer is meron tayo tinatawag na radiation. Okay? So yeah, meron tayong intro, but then again class, more or less, ang pinaka-definition natin class na radiation is ito. So no medium is required class. Heat is transferred without the use of a medium. Okay? Kasi class ang mag-propagate naman dyan or mag-travel is yung electromagnetic waves. Okay? So electromagnetic waves natin, class pwede siyang parang iba-iba yan. Depende class sa wavelength natin. So it's either radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-ray or gamma rays. Yun yung parang types class ng ating electromagnetic waves. Okay? So dahil sa mga waves na yan, class, heat is transferred. Okay? Tapos, yeah, meron tayo dito class. So rate of heat transfer by radiation also depends on the object's color. So nasa spectrum kasi ito eh. Kasi di ba gamma rays more or less. So may effect daw class yung color dun sa ating rate, kung gaano kalaki yung rate of heat transfer natin class, no? Kasi daw class pag black, most effective yan. Pag white class, least effective, or like yung transfer ng heat natin class, hindi masyado effective pag puti. Mas effective siya class pag black. Okay? Yan. Tapos isa pa class, a perfectly black object would be an ideal radiator and an ideal absorber. Pakita natin dun sa picture mamaya class. A perfectly white object class. So white is either white or clear. Ito mirror. Reflects all radiation. Okay? So ito class yung ating picture yan. So binibida natin dito sa picture class kung titignan nyo. Black kasi class is diba better. Yeah, color black kasi class is a better absorber tsaka emitter. Okay? Ibig sabihin class, mas na-absorb niya yung heat. So, mas mainit siya. Compared class sa gray. Kaya kung titignan nyo sa picture class, ang pinaglalaban natin sa picture, mas magme-melt yung ice kapag andito siya class sa black. Kaysa dun sa gray pavement. Ito pala class is asphalt. Ito naman class is gray pavement. Okay? So yan, may effect daw yung color kung gaano ka yung heat transfer natin. Okay? Tapos dito naman class, pag-usapang radiation kasi class, meron tayong parang na-absorb tsaka nare-retain. Okay? So more or less, yeah, nare-reflect. So pag black yan class, malaki yung na-absorb niya, malaki rin yung nare-release niya. Okay? Pag puti naman class, silver or white yan class, mahina siya mag-absorb ng heat, tapos mahina rin siya mag-release. Okay? So mathematically class, ang color is represented by emissivity or yung letter E. Okay? A black radiator would have ito, E equal to 1 kasi malakas siya class. Okay? Pag puti naman yan class, perfect reflector transmitter, yung E is equal to 0. Okay? So same class, ganun din, meron tayong rate of heat transfer, yung P. Okay? So ito class, nakabase siya dun sa law of radiation ni Stefan tsaka si Boltzmann. Okay? With that class, they formed a formula. Dito lang class, medyo kailangan lang natin i-refine ng konti para dalawa lang kasi yan class. Pag either dalawa yung temperature na bigay or isa. Okay? So pag dalawa kasi yung binigay class, ang kinukuha natin is yung net or yung net heat transfer. Dito class, i-consider mo yung temperature ng object mismo tsaka yung temperature ng surroundings. Pag isa lang naman yung given class, more or less, ganyan yung formula niya. So pag isa lang yung given, ang kinoconsider lang natin class is yung temperature ng object mismo. Same dito class, no? Kung titignan nyo yung ating coefficient class, naka-Kelvin tayo. So dapat class lagi ang unit ng ating temperature class, consistent tayo. So dapat laging naka-Kelvin. Okay? Yan. So kung titignan nyo class, may chance tayo na mag-negative. Kasi diba, may chance na mag-negative class yung ating temperature. Depende kasi sa temperature ng surrounding class to yung temperature ng object. So pag nag-negative class yung ating sagot, diba, it's either kasi inabsorb niya or release niya. So pag negative yung sagot class, ni-release. Diba? Dito yung absorption or release. It's either inabsorb niya or in-emit niya. So pag negative class means the radiation was emitted. Okay? Pag positive class, it was absorbed. Okay? Summarize natin class, tapos sagutan natin yung next problem. Last problem. I-erase ko lang. Again class, summarize natin. So yung third way class is yung tinatawag natin na radiation. Okay? Formal definition natin class ng radiation is yun by, so heat is transferred by absorbing or emitting. Double M bang emitting? Emitting magnetic. So shortcut na natin. Radiation. Yan. Okay? Tapos class, meron tayong formulas. So, ang formula natin class, same, no? Again, meron tayong P is equal to Q over T lang tayo dito class. So, gagamitin natin yung Stefan-Boltzmann law of radiation. Tapos, in terms of formula form class, ganito yung tsura niya. So, yung sigma times yung area times yung E tapos yung temperature is to 4. Okay? But then again, class, gusto natin kunin yung net or consider natin kasi temperature surrounding, mag-iiba siya. So, meron tayong delta A, E. Tapos, ito class, meron lang tayong T2 minus yung T1. Tapos, 4, 4. Okay? So, difference sila dito class, again, ang tawag natin sa T2 class, ito yung temperature ng surrounding environment. Pag T1 class, ito yung temperature ng object. Okay? Pag yung simpleng T lang class, more or less, ang binibigay niya is yung temperature ng object. Okay? So, yan. Tapos, meron tayong constant class. So, this time class, yung ating coefficient, laging consistent sa class. Okay? So, yung ating sigma class, isang tawag natin dyan is yung Stefan-Boltzmann constant. This is equal to class 5.67 times 10, negative 8 watts per meter squared K to the 4th Kelvin. So, again, class, Kelvin tayo dun sa constant natin. So, dapat yung mga temperature natin naka-Kelvin. Okay? Tapos, pag hindi siya nagbigay ng E class sa problem, pero sinabi niya class na ideal reflector siya. So, pag sinabi niya ideal reflector yan class, ibig sabihin wala siyang ina-absorb. Technically, ito yung color white. Or yung clear. Okay? Or transparent. Is equal to 0. Pag sinabi niya naman class na ideal absorber, ito class yung black. So, pag kayang-kaya niyang mag-absorb class, E is equal to 1. Okay? So, yun lang naman class yung kailangan nating tandaan. So, with this class, kaya na nating sagutan yung example. So, yung example natin class is example 10.3. Erase ko lang, no? Okay. So, last problem class, sagutan natin yung 10.3. So, dito class, kung titignan nyo, gusto na ng problem, tinatanong na lang niya kung ano yung rate of heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22 degrees Celsius. Tapos sinabi niya na normal skin temperature is ganyan. So, kunin lang natin class. So, may nakahubad daw class sa isang dark room. Ano daw yung rate of heat transfer by radiation niya with respect to the dark room. Okay? So, given tayo class. So, ang given natin class, kung titignan nyo, meron siyang binigay na ambient temperature. So, pag sinabi kasing ambient temperature yan, class, so yung room, so yung surrounding yan, class, so T2. So, meron tayong 22 degrees Celsius. Okay? Next class, binigay niya yung skin temperature. So, ang pinag-uusapan kasi natin dito, class, is yung transfer ng person. So, ito yung object natin, class. So, ito yung T1. So, meron tayong 33. So, 33 degrees Celsius tayo dito, class. Yan. Okay? At okay, ibang given class, meron tayong given area equal to 1.5 meters squared. Meron rin tayong given class na emissivity is equal to 0.97. So dito pala class, ang range lang natin is from 1, 0 to 1 tayo. Kasi parang 100% class, yun na yung pinaka-ideal. Okay? Yan. So, sagutan na natin class. Ito. Huwag natin kalimutan class yung constant natin. Yung ano, yeah, equal siya class sa ating 5.67 times 10 negative 8. Ang unit natin class is watts per meter squared Kelvin to the 4th. Okay? So again class, di ba nga, since dapat consistent tayo sa unit class, tapos ito yung ano ng constant natin, ito yung susundin natin. Kung siya yung mag-prevail. So ito class, kailangan nating i-convert. So para ma-convert lang naman yung Celsius into Kelvin class, mag-add lang tayo ng 273. Okay, so with this class, meron tayong 295 Kelvin. Ito naman classes, meron tayong 306 Kelvin. Okay, so meron tayong isa lang naman formula natin dito class, diba? Ang formula natin dito class is power. Mulat ko ba? O, nag-summary siya tayo, diba? Power class is equal to yung sigma. So, since dalawa yung given yung class, change yung temperature tayo dito. Sigma yung A, tapos yung emissivity, times yung T2 to the 4th. minus yung T1 to the 4th. Okay? So, titignan nyo class, given lahat, direct sub lang tayo. So, meron tayong 5.67 times 10, negative 8. Okay? Times yung area natin class. So, consistent lang tayo sa units class, no? Tapos, E na 0.97. Okay? Minus yung first class. So, meron tayong 295 raised to the 4th. Minus yung 306 raised to the 4th. Okay? So, titignan nyo class, ang power natin magiging negative. Meaning class, yung radiation natin or yung heat natin class na release, na emit. Okay? Again, calculate natin yan class. Meron tayong 5.67 times 10 negative 8 times yung area natin class na 1.5 times yung emissivity natin class na 0.97 times yung 295. Again class, dapat yan kasi naka-Kelvin tayo, no? Okay? Minus yung 306 raised to the 4. Yan. Okay? So meron tayong sagot class na negative 98.5321. So anong unit natin dito class? Since consistent naman tayo sa units class, watts tayo. Kasi more or less, saan natin kinuha yung watts? Andito siya sa ano. Kumbaga ito magka-cancel, ito magka-cancel. Okay? So titignan nyo class, tama ba yung sagot natin? Yeah, tama. So again class, ang meaning lang ng negative sign dito, na-emit or na-release. Okay? So pag negative class, emitted. Pag positive, absorb. By the object. Okay? So, itong problem solving strategy natin class, more or less, pinaglalaban lang naman natin dito kasi yung steps. So, yun. Ganun lang naman class, di ba? Alamin mo kung ano yung anong method ng heat transfer, okay? So, identify class ano yung required. Tapos, ilagay mo class kung ano yung given. So, ano yung given, okay? Tapos anong formula yung gagamitin. So in terms of formula class, dapat alam mo lang kung ano yung required, ay anong method yun. For every method kasi class, may iba-iba tayong formula. So pag conduction yan class, meron tayo ng cat-D. Kapag naman convection class, meron tayo ng hat. Tapos kailangan mo i-consider class yung phase change. Okay? Pag radiation naman class, meron tayo ng OAE2. OAT. Okay? So after na, substitute mo lang lahat ng unknowns. Dapat lang maiwan doon class na unknown is isa lang para ma-solve mo. Okay? So check the answer class if it is reasonable. So more or less class, dahil nag-stay kayo class, meron tayong pakulos dulo. Okay? So ito, sa mga hindi pa marunong manligaw, ito yung galawan natin manligaw class. Okay? So usapang characters natin class, ako, tapos si Bebang. So more or less, sabihan mo lang siya class. So paano ba manligaw? Papaalam ka ba or hindi? Ito class subtle. Okay, so mag-high crush ka lang. So magugulat siya, no? Sabihan mo siya class nung I'm lost. So gulat na nga siya, confused pa siya. So sabi niya so, sa Tagalogin mo, ligaw ako. Yeah. Thank you class for staying. This ends our discussion for module 10. Thank you. Good day. See you around. Stay safe. See me at my next video. Bye.